All right, in the second lesson here, we're going to get into arithmetic series. So in the first lesson, we were doing arithmetic sequences. The only difference between a series and a sequence is these plus signs that you see right here. So a series simply means a sum of a sequence. And so if we take a sequence and we add all the terms together, you have a series. So the main formula that we're looking at for this guy is the one that you're seeing right here. Again, these are all from your formula packet. So again, these are the 5 formulas that we're looking at for this chapter right here. And so this is the arithmetic block that we're looking at here. So this was the first one that we looked at. This is really used for finding specifics, either a general rule for the sequence. Oftentimes we'll use this to find a specific value of a term. Like if we said, what is the value of the 20th term? That's what this thing is used for. The S of n formula are used for sums. And so anytime you're asked about a sum, this is your go-to. You'll notice there's 2 formulas here. One is shorter. This one on the right is shorter. This one right here is longer. The difference between the two is you can only use the shorter one in certain cases. You can always use the longer one. To use the shorter one, here's what you would need to know. N represents the number of terms. So if we said find the sum of the first 20 terms, n would be 20. Okay, so it's the number of terms. U of 1 is the first term in the sequence. And U of n is the value of the last term. So if we said find the sum of 20 terms, this would be a 20, and this would be the value of the 20th term in the sequence. And this is where the limit comes in. If you don't know what the 20th term is, you can't use this formula. So that's when you would have to go with the longer of the 2 formulas. But this one always works, so you could always just use this one all the time. But this one is nice if you have enough information to use it. So going back to our notes, part A, find the sum of the first 5 terms of the series. Notice that you could do this without a formula. Right? I don't need a formula to find the sum of the first 5 terms. Obviously, if I continue the pattern here by adding 3 every time, I know the 5th term is 10, and so I could just add those 5 terms by hand and get my sum that way. And that works, and that would work for part B as well. Find the sum of the first 20 terms. I could find all 20 terms and add them all up, but we're talking about efficiency here. We want to do whatever is quickest and whatever is the most efficient. When it comes time to take a test, you don't have 5 minutes to do a 1-minute problem. So you want to make sure that we make use of formulas for the sake of efficiency. So if you look at part B, here's how the formula would work. And again, I'm using the longer of the 2 formulas because when it says find the sum of the first 20 terms, I don't know what the 20th term is. And so I can't use the shorter formula. So we're going to use the longer one here. But again, if I just start plugging in numbers, and you're going to see this as U1, it's the same thing, but this just represents the first term in the sequence. So we got the number of terms. So if I'm finding the sum of 20 terms, then that's a 20. This is the first term, which in this case is -2. Again, this is the same n as this n, so this would also be a 20. And then my common difference is +3 for this one. So if we just sub in those numbers, and the rest is calculator work. But if you're following along with the video, you might want to give this a try in your calculator just to make sure that you are getting the correct sum. Going on to the second example. Right here, so a little change in the question. Now they're saying, when will the sum be 1,000, or how long would how many terms would it take to get a sum of 1,000 on this one? So now they're giving me the sum, and they're asking me to find n. So if you kind of go back to the formula that we're working with here, they're giving me the sum of 1,000, and they're asking me how many terms would it take to get there. So now we're solving for n. So if I plug in all the information that we know, my sum of 1,000, I leave n as n because that's what we're trying to figure out. I got my first term is 20. We got the common difference is +3, and so this is the equation that we're solving. We're solving for n. This one comes with a little extra challenge because you have 2 n's, and so do a little cleanup here. So we distribute the 3, and that gives me this right here. Obviously 2 times 20 is 40. So doing a little cleanup, and I'm going to go one more step. I can combine the 40 and the -3 to get this look right here. So here's where you got a couple options. I can use a calculator. I can do this by hand. Let me give you a few options. Here's one way to take advantage of a calculator to solve an equation like this. What I'm going to show you right now actually works for any equation under the sun. So it's a really nice tool. So give me a minute. I'm going to set this up in my calculator. Okay, so to solve an equation, one way of solving is to graph the left side of the equation as one graph, graph the right side of the equation as a second graph, and then simply find out where those two graphs intersect. And that would be your solution. So that's the way I'm going to show you right now. So you can see I graphed the 1000, which was the left side of the equation. I got the n over 2 times 3n plus 37 on the right. And I'm simply going to graph that. The one thing that you're going to have to toy with a little bit is the window. Because this is a really big number, these guys are going to intersect somewhere pretty far outside of my normal window settings. If you think about a graph of y equals 1000, that's a horizontal line going through the y-axis at 1000. So my y maximum has to be at least 1000 in order to see this graph right here. So I'm going to have to toy with my window a little bit. So in this case, let me go to my window. The x's I'll come back to. We'll see what my graphs look like here. But my y maximum, let me go at least over 1000 to make sure I get the y equals 1000 graph on my screen. But let's take a look. So I'm going to hit graph. So there's the y equals 1000. The other graph, there it is. So I'm almost there. It's somewhere off to the right. So I need to go farther to the right. So let's increase the x maximum so I can go farther to the right. So I'm going to go into my window, my x max. Let's just go to 30 and see if that does it for us. So I'll hit graph. So there's the y equals 1000. Here comes the other graph. And it looks like we got a winner. So there's my point of intersection. So if I go under calc, and choose intersect, and then enter, there's my point of intersection. So right there where x is 20.4 is our solution for n at 20.4. So, and you can see on here, right, that's what I was coming up with from another method, but about 20.4 works. So here's one thing you got to consider when it comes to working with situations like this. When it comes to a number of terms, how many terms would it take to reach my sum of 1000, right? When it comes to term numbers, you're always going to have integers. 1 term, 2 term, 3 terms. We're never like in between terms. So consider this for a minute. If I added the first 20 terms together, would I be there yet, right? Notice this took a little more than 20 terms. So once I add up the first 20 terms, I'm still going to be a little shy of 1000. I'm going to need that extra term, the 21st term, to reach over 1000. So we would say, reasonably on something like this, I would need to add up the first 21 terms in order to get a sum of at least 1000. One other way of solving this guy in the calculator is if you go through a little distribution here. So that's what I distributed and got this look right here. I multiplied the 2 over, distributed the n. If I subtract my 2000 over and get the quadratic look, make it equal 0, you can also solve a quadratic in your calculator. So I'll show you how to do that really quick as well. So keep that image in mind, and we're going to do the 3n squared plus 37n minus 2000. So if you go to your calculator, if you have at least one of the newer calculators, this will be there for you, but it's under the apps button. So I'm going to hit, let me quit. I'm going to quit to my main screen. So I'm going to hit apps, and if I go down to the one that says Polysimul 2 and hit enter, number 1, just hit enter, the root finder. The 2 is highlighted because it's quadratic. That represents the highest degree or the highest exponent within the problem. If you see these buttons right here, these just correspond to the button below them. So if I want to hit next, I hit the button below it, which is this guy right here. And I'm simply going to plug in the numbers that we have. So we had the 3n squared. So I'm going to put my 3 in for him. So 3n squared minus 37, minus 37n plus, or sorry, minus 2000. So minus, enter, 2000, enter. So I'm literally just subbing in the numbers from the quadratic. Let me make sure that's right. So right here, so 37n squared plus 37n minus 2000. So I'm going to change that to a plus. 37n minus 2000, and where it says solve, so I'll hit the button below solve. And there you go, I get my two solutions. So notice the first one, I got my 20.4. The other one we can disregard because you cannot have a negative number of terms. That wouldn't make sense. So when it comes to a number of terms, this has to be positive. So there's my 20.4. You do have, if possible, there's a way of turning that into a fraction. By hitting that button right here, you can get a fraction. But this is an irrational number. You're not going to get a fraction out of that. So 20.4 is good. So that's another way of solving equations. That's a great way of solving quadratics in general, is with the polysimult 2 root finder. So there we go. Moving on. So last part of this lesson, we're now looking at something called sigma notation or summation notation. Same thing. This is the Greek letter sigma that we're looking at for this one. So this always represents a sum. So whenever you're finding the sum of a certain amount of terms, we use this guy for that sigma. So here's a couple examples, and this can go into your calculator, which is going to make this really easy. But let me just tell you what's going on here. What this means is I would be finding the sum of terms 1 through 15. So the sum of the first 15 terms. And this is the rule so that I'm looking at right here. So if I ever wanted to know what those 15 terms are, I plug in the numbers into the rule to get them. So if I wanted to know the first term in the sequence, I plug in a 1 right here. So 3 times 1 minus 4 would give me the first term in the sequence. If I wanted to know the second term of the sequence, I would plug in a 2. 3 times 2 minus 4 would give me the second term in the sequence. If I wanted to know the 15th term, plug in a 15. So 3 times 15 minus 4 would give you the 15th term in the sequence. So there's two ways to do this. One is with a formula. So we have the shorter formula that I introduced you to. Let me show you that real quick. So that's this one right here. So for the one that we're doing, I know the number of terms. There's 15 terms. I know the first term because I plugged in a 1. I know the value of the 15th term because I plugged in a 15. And so I have all three of these pieces of information, so I could use the formula. And that's what you're seeing right here. So I subbed in the 15 for n. Here's the first term. Here's the value of the 15th term. And if I clean that up, I get 300. And so that works using the formula. The other way you can do it is there is a calculator tool for this. So let me show you that as well. So let me bring up the calculator. I'm going to see if I can show you here at the same time where you're looking at this. So if you go to the calculator, quit. Okay, so if you go to the calculator under math, so under math, if you go all the way down, so I went up to go down here. I'm going to scroll up in order to get to the bottom quicker, so I'm just going to go up. And if you see the one right here that says summation, that's what we're doing right now, so I'm going to hit enter. And I literally plug in the same things that I see on my computer screen. So right here where it says k equals 1, sometimes it'll say n equals 1, it might be I equals 1, it doesn't really matter. This just refers to which term you're starting with. So in this case, we're going to start with the first term. This is the term you end with, so the 15th term. So again, that just means I'm finding the sum of terms 1 through 15. And so I'm going to use my X button right here. So I'm going to hit X. I'm going to hit 1. I'm going to hit over. We're going to put a 15 at the top. I'm going to go over. I'm going to type in the rule, which is 3x minus 4. And I'll hit over. So I'm just typing in the same thing onto my calculator screen that you're seeing right here. And when I hit enter, there's my sum. I got 300 for my sum. So that's another way of doing it. It's real easy with the calculator that way. So there's my sum of 300. So if you want to try that with one more, here's the last one that we're going to do. The first thing you got to do on this one, though, is do a little substitution. They're giving me a general scenario here. I'm going to find the sum of 50 terms. So terms 1 through 50. According to this rule, but I got to use a little substitution. So u is 3 plus 2i, so we're going to sub in 3 plus 2i right there. V is this one, so I'm going to sub that in for V, and this is the look that we're going with. Okay, after I do a little substitution, let's simplify. So distribute the 3, combine like terms, and I now have a simpler rule to work with. But again, I could just go back to either the formula or the calculator feature. So if you're trying this by hand, give it a shot. Again, I could either go with the short formula that we used up above, which is what you're seeing right here, or I could go with the calculator summation notation that we saw in the calculator and just plug in this for the rule, and I can get the sum either way. So either with a formula or calculator, both are fair game.